civil engineers, as structural engineers, are taking up the construction. If we are not taking care well, then the left side is the fate, and if we are taking care well, then probably we can have this right side of the photograph to be having the safe construction designed or executed by us. So the mainly this chapter will have these contents. I would say that the contents of the IS 456 would cover section wise. There are some sections of the code which is like in section 1 we discuss about scope, section 2 about materials, workmanship, inspection and testing. Section 3 is general design considerations. Section 4 is the special design requirements. Section 5 is structural design with the help of limit state method of design. And then we have some annexures of this standard, which will also be discussed briefly. And these A to H are the annexures, which will be which are part of the IS 456, and we will have a slight look on that also. So coming to the first section, which is the scope. Now, if we understand about this RCC, then the scope deals with the general structural use of plain and reinforced concrete. So we will be discussing about how we can make use of it and the design aspects of the design aspects using IS 456 for the reinforced concrete structures. For the purpose of standards, this standard, now IS 456, when we talk about this 456 standard, when we use plain concrete structures, these plain concrete structures are those structures which may be just simply PCC, it means without any reinforcement, or if this reinforcement has been provided in the concrete and is not considered for the determination of strength, then that will also be considered as PCC. So this is the scope. And now coming to the section 2. Section 2 of this 456 talks about materials, constituent materials of the concrete, then about concrete formwork, then assembly of reinforcement, transporting, placing, compaction, curing, concreting under special conditions, acceptance criteria of concrete, and then inspection testing of the structures, whether whatever we had intended as per the concrete design requirements or the concrete quality, whether we have all achieved or not. So, dear friends, the basic constraints of the concrete, the materials for the concrete, if we consider, this slide shows the general requirements for the RCC, wherein cement is basically the important aspect for the concrete mix design, wherein the cement plays the role of binding the different aggregates and the materials. Then we have some provision of general admixtures. Now these admixtures can be integral part of the concrete as cementitious also, and there may be some other chemical admixtures also. Then we will be discussing about some aggregate water admixtures. Now here when we are writing admixtures at a later stage, it is the chemical admixtures for the performance improvement. There may be various requirements for the concrete, maybe say early setting, maybe some super plasticizing requirements. So those kind of admixtures can also be added in the concrete, and then reinforcement. Now, presently in IS 456, we are dealing with the reinforcement, which is steel reinforcement. But now you would be knowing there are some other types of reinforcement also coming. FRP bars are there, and there may be other options also available to be used in concrete, but that is not the part of our scope. One thing more I would like to mention here, that IS 456 is also being updated, upgraded, and the revision is in progress. And you may see in near future some more detailed informations and some improvements in the codal requirements in time to come. At this moment, what is the prevailing standards requirement we are discussing. Now, as we discussed, the cement is a very important part of the concrete, and there are different types of cement which can be used based on the requirements of the concrete. Generally, we use ordinary Portland cement or maybe some cements which are based on fly ash or calcined clay or GGBS. So in the revised standards, probably we may be having general purpose cements and special purpose cements. So in general purpose cement, at least we can consider or OPC, the ordinary Portland cement, which is conforming to IS 269. Now, I have specifically mentioned the year because in 2015 revision, all the grades of the OPC have been covered within this standard. Then we have rapid hardening Portland cement conforming to IS 8041. This is a special type of requirement and different special cement for specific requirements. Then we have Portland slag cement, what we call as PSC also. PSC cement is also a general purpose cement and it should be as per IS 455. We generally nowadays using the available market, the available cement in the market is PPC, Portland Pozzolana cement. So Portland Pozzolana cement is also of two types. In one type, the pozzolanic material is fly ash, and in the other PPC, the pozzolanic material is calcined clay. So there are different standard numbers for different cement. If we have PPC fly ash based, then it is IS 1489 part 1. And if we are using Portland pozzolanic cement with having calcined clay as a pozzolanic admixture, then it has to conform to IS 1489 part 2. Now we have some other special purpose cement also, like hydrophobic cement conforming to IS 8043, low heat Portland cement conforming to IS 12600, sulfate resisting Portland cement conforming to IS 12330. So here I would like to give you a brief understanding about how we select the cement for our purpose for the concrete RCC works. As I already explained that there is some general purpose cement which we can use for any general condition like OPC, PPC and PSC. These are the cements which give normal performance. The difference mainly I could consider is that the PSC and PPC are more environment friendly or maybe greener cement because they are using lesser carbon emission aspect from carbon emission aspects. These are environmental friendly or more greener materials. OPC is also can be used as per the design requirements. And the other cements like rapid hardening Portland cement or maybe low heat Portland cement or maybe sulfate resistant Portland cement, all these type of special cements are generally designed based on the environmental conditions or site specific conditions. So IS 456 gives you the guidance of using available cements. One thing more I must mention here that nowadays everybody probably knows that the cement which is available in the market must bear the ISI marking. Now, no manufacturing can be done for the cement which is not meeting the IS code provision requirement, IS specification requirements. So these are the specification standards, and whatever cement we are getting, it must meet any of the specified cement specification and must bear the ISI mark. So when we have already seen that we have cements which are having some mineral admixtures like PPC, PSC, slag and all, but otherwise we can have in concrete also directly usage of the mineral admixture. Even if we are using OPC, ordinary Portland cement in the concrete mix design. So besides Portland OPC or ordinary Portland cement, we can add some pozzolanas like fly ash, silica fume, rice husk ash, and ground granulated blast furnace slag, what we call as GGBS. So when we use these mineral admixtures, now it is important to understand why we are calling these as admixtures. Now, admixtures is that it is not that these are the very essential part of the concrete, but these are admixed in the concrete. These are added in the concrete for some special benefit or some special property or some other gains what we can get from the concrete. And these additives are used. And the pozzolanas, when we talk, these have these properties of binding in presence of OPC. What happens is that when the hydration of OPC takes place, a lot of calcium hydroxide is made in the chemistry. If we consider the chemistry of the hydration process, this calcium hydroxide is available in the hydration process of the OPC. And this calcium hydroxide, when reacts with reactive fly ash or silica fume or rice husk ash, it also makes the binding chemical and acts like cement. So even if you are not using OPC to the full extent, suppose for a mixed design you are using 400 kg of OPC, and in one design you are using 300 kg of OPC and 100 kg of mineral admixture. So in a way we can say that in both of the designs we are having 400 kg of the binding material. In first case, OPC is a full 400 kg, and in the other case, OPC is 300 kg and 100 kg is the mineral admixture, which will be acting as a binder in the concrete. So for different pozzolanic admixtures, we have in IS 456 given different limits of usage in the concrete. The fly ash upper limit is 35% of the total binder. So if we are using say 300 kg of total binder, out of that maybe 100 kg could be fly ash and 200 kg could be OPC. Silica fume is very costly material. It is added in a very small quantity for the special performance improvement. Similarly, rice husk ash and other mineral admixtures are used according to the design mix requirements. When we talk about GGBS, ground granulated blast furnace slag, this slag is, if reactive, it can act just like cement and can replace the requirement of cement by 60%. So in a concrete mix design, in fact, the slag quantity can be more than the OPC. So generally when we make the concrete, the materials aggregates are generally used for making the normal concrete. These are normal density aggregates, and for most works we use 20 mm aggregate size as the maximum nominal size of the aggregate. And we generally try to make our general design mix with 20 mm plus 10 mm down aggregate sand and other things. So generally 20 mm aggregate size is suitable for normally RCC works. But when there is no reinforcement, or we may use higher size of aggregates, then, or maybe there is no high restrictions of the flow or workability, then 40 mm or larger size concrete, larger size of aggregates may also be permitted. So generally what we see is for the plain cement concrete PCC works, if the thicknesses are larger, then we can go for 40 mm or larger sizes also. For RCC also, where we have very low requirement of high workability and the reinforcement congestion is not there, we can go for 40 mm size aggregates for normal strength concretes. However, as a general practice in India, we are generally using 20 mm down aggregate size for the as aggregates for the concrete. In concrete elements with thin sections, closely spaced reinforcement or small cover considerations should be given to use 10 mm nominal maximum size. So if we have a congestion and if there is a risk of say honeycombing or something like that because of the concrete flow issues, then we can make our concrete mix design with 10 mm nominal maximum size of aggregates for the RCC concrete. Coarse and fine sands shall be batched separately. When we make the concrete, the coarse and fine aggregates. Now, coarse sand coarse aggregates. There is a distinction that when we batch the concrete, we have coarse aggregates and fine aggregates. The coarse aggregates is generally the 10 or 20 size of aggregates, and fine aggregates is basically the coarse sand. Now, section 2, again for materials, we talk about water. Now, water plays very important role for the quality of concrete. Generally, we are adding water for two purposes. First purpose is the addition of water for the hydration of cement, to make the cement as a glue material, binding material, and some free water is also added for the flow requirements. So water is there in the concrete, even some water remains within the concrete even after the hydration of the cement. And the quality of water plays a very important role when we consider the quality of the concrete as a whole. In terms of long-term durability considerations, there are some special considerations. And also the pH of the water also plays a role for the development of the strength of concrete during the hydration process. So this code suggests that the water used for mixing and curing shall be clean and free from injurious amounts of oil, acids, alkalis, salts, sugar, organic materials, or other substances that may be deleterious to the concrete or steel. It means any element which can harm the concrete or steel should not be there in the water, because water will be then part of the concrete constituting elements. And when we use water for the curing purpose, the curing water should also be clean, because curing water can also penetrate inside, and if the curing water is having harmful elements, then it can also harm the concrete. So generally we consider the potable water to be satisfactory for the mixing concrete. Potable water means the water quality which we can drink. So the potable water quality parameters are separately given in other specifications for the potable water. So the quality of water, if it matches with the potable water quality requirements, that is considered to be satisfactory for the concrete purpose also. The pH value of water shall not be less than 6, because if the pH value is less than 6, it means it will be acidic, and the acidic water is going to harm the concrete strength process also. And because our concrete during the hydration process of cement becomes alkaline, so acidic water can affect the overall hydration process and strength and otherwise durability also. So the water quality parameter is governed with some values based on laboratory test. And the potable water permissible limits is like for organic, inorganic, sulfates, chlorides, suspended matter, all tested as per IS 3025 different parts. The permissible limits are given as shown in the table. Specifically the sulfates and chlorides are considered to be most serious elements in terms of durability of concrete. The sulfate content, if tested as per IS 3025 part 24, shall not exceed 400 milligrams per liter. Similarly, chlorides, if given as per tested as per part 32, for PCC considerations, the 2000 milligram per milligram per liter is the limit. However, for RCC concrete, this limit is 500 milligrams per liter. For suspended matter, 2000 milligrams per liter is the limit. Now we use some chemical admixtures as well, and the chemical admixtures, if used, shall comply to IS 9103. Now the admixtures which are used in concrete for various property enhancements like flow, superplasticizers are very, I would say, very beneficially being used in the concrete for many different kinds of benefits. Commercial benefits is also there, and and you make very good concrete with very low water cement ratio with the help of these chemical admixtures. So if we are using some admixtures like this, the admixture quality should be such that it should not impair any durability risk to the concrete, nor combine with the constituents to form harmful compounds, nor increase the risk of corrosion of the reinforcement. So admixtures may have some chlorides also, may have some other elements which can harm. So all the limits are to be kept in control so that there is no risk of durability of concrete or the corrosion of the reinforcement. If two or more admixtures are used simultaneously in the same concrete, the data should be obtained to assess their interaction and to ensure their compatibility. Now, they should not harm each other and they should not harm the concrete as such. Then we have reinforcement. When we talk about RCC, now RCC is reinforced cement concrete. It means with cement concrete, we have some element of reinforcement, and that reinforcement has also to be controlled. There are different IS codes which govern the guide, which govern the material specification. Mild steel and medium tensile steel bars conforms to IS 432 Part 1. High strength deformed steel bar conforming to IS 1786. Now, hard drawn steel wire fabric. Now, hard drawn steel wire fabrics are generally used for pre-stressing purposes, and that should conform to IS 1566. And structural steel conforming to grade A of IS 2062. So these different reinforcement we can use in the RCC system. Now, this, if we talk about IS 1786, it is the most popular standard today, and most the steels are conforming to IS 1786. And in IS 1786, there are different grades of steel. Generally, earlier we were using Fe 415 grade, 415 strength, 415 newtons per mm square strength grade. And now with the help of process improvement, and I would say this thermomechanically treated bar, TMT bars, are now having better strength than 415. So nowadays in the market, you are getting Fe 500 and Fe 550 or even Fe 600 also. So in Fe 550, we have 2-3 grades available. One is normal grade, Fe 500, normal strength grade. Then you may have ductile grade, what we call as Fe 500D or Fe 550D, and maybe some better steels are also having better ductility, and we can have Fe 5S also, super ductile something. Coming to concrete, again, now concrete is characterized or graded by strength. Generally, we call as M10 to succeeding with the gap of 5. We are defining different grades of concrete. Standard concrete we can consider M25 to M55, and high strength concrete M60 to M80. And nowadays, the strength even higher than M80 is also available in the technical domain. Some RMC plants are making higher strength, and nowadays for very special structures, M60 to M80 concrete grade is also being used popularly. Earlier, we were using mainly the standard grades of concrete for all types of structures. So, as the table shows, suppose I take standard concrete of M25. So, for M25, the characteristic strength should be 25 MPa as such. So, the minimum defined strength criteria, if we consider for RCC grade of RCC mix, M25 is the minimum strength grade criteria we are considering. For lower grades, M10, M15, M20, these are generally being used as plain cement concrete. So in RCC, when we use M25 and the characteristic strength defined is 25 MPa, then what does this mean? Do we mean that average strength should be 25 or minimum strength of concrete should be 25 or something different? Now, this is very important to understand. Here, the word written is characteristic strength. So, characteristic strength is defined as where, because when you will make concrete, concrete is a heterogeneous material, so it may not have strength uniform. If you will make four times you will make, every time you will have some different strength. So statistically, if we analyze, then this characteristic strength for say M25 grade may be defined as, if we take 100 samples, 95% samples should be having strength more than 25 or 25, and only 5% samples can fail. So in other terms, if we define characteristic strength, the characteristic strength may be defined as the strength in which not more than 5% samples should fail. If it would have been average strength, then average means 50% high, 50% low. So if we consider 25 to be average, then it means for 50% samples, the strength could be lower, and for 50% samples, strength could be higher. So average could be 25. But in IS 456, we are not considering the average strength. Please keep it in your mind. It is the characteristic strength what we have to be considering, and we are asking that 95% samples should have strength equal or more. Only 5% samples can have some slightly lesser strength. So this is the special criteria. We will be discussing the acceptance criteria also. So the properties of concrete is like the strength increases with age. There may be some shrinkage because the hydration process is a exothermic reaction. The temperature increases and then it cools down. There will be some shrinkage. There will be some creep of concrete. There will be some thermal expansions. Then we have tensile strength of the concrete to be considered in designs, and there may be elastic deformation. So all these basic properties generally we consider when we do the structural design or the concrete design. Now, if we talk about a good concrete should be very cohesive and should have reasonably required workability. So for normal concrete, shallow thickness, for say foundation type of thing, where this reinforcement is not very dense, we can have some low workability also, and it can be defined as the compaction factor to be 0.75 to 0. And pavements, pavers, mass concreting, where we can have slightly low workability, the slump could be 25 to 75 mm. And as we go with the RCC structures, and we have some requirements for the high flow because of the reinforcement bars and the section sizes, the thicknesses, the width, all these aspects are important. And for those considerations, we can have workability with slumps of maybe 50 to 100 for reinforced sections which are having some normal permeability, normal workflow requirements, and in some cases we can have requirement of more than 75 mm also. In special circumstances, we can have very high slump requirements, and for those cases we should have slump between 100 to 150. For trimmy concrete, for the concrete which is to be pumped for the purpose of placement, we are using pumping and trimming, the flow requirements could be even higher. So we have to design the concrete mix as per the workability requirements. Now coming to durability requirements given in IS 456. Now there are various factors which can affect the concrete durability. Important factors could be the environment. The environment may be normal and environment may be harsh. Then we have cover to the embedded steel, because if the cover is not adequate or cover is lesser, then the damage to the reinforcement steel could be at a lesser age. And if we have good cover, then probably we can we can have larger life, better life of the structure, because of the deterioration of the steel would take lot of time to reach, because if there is an external attack from the outside, maybe carbonation or some other things we can discuss. And because of all this, if there is a aging effect, if the cover is good, then we can save our reinforcement steel for larger time and can give better durability. Type and quality of constituent materials. Now, constituent materials quality, like as we discussed, water quality, the aggregates quality, cement quality, all these materials would have very important role to play when we consider the durability. Coming to cement content and water cement ratio of the concrete is also very important when these are the points we consider for the design mix. Generally, we consider that if the deterioration is because of carbonation effect, then if cement content is good, then carbonation process will be slow and we will have better life. If cement content will be lesser, then carbonation process may take faster pace and can affect our reinforcement and the concrete at a lesser age also. And then we talk about free water cement ratios. Cement content and water cement ratios both are very important, because if you have provided enough kgs of cement, which can help, but if you have provided additional water than the requirement, this additional water will be available within the concrete, and because of the higher content of the water, the strength will also be reduced. The free water will be available within the concrete, and it can accelerate the deterioration process. So to have good quality concrete having good strength and durability properties, we have to see that the cement content should be good, as per the code has given values that for this grade of concrete, minimum cement content should be like this for a different environment condition. We will discuss here. And then the maximum water cement ratio is also to be controlled. Then again, the very important aspect for durability is the workmanship, proper compaction, efficient curing. All these things are taken care, then your deterioration will be very, very slow and you will have very high durability. And shape and size of the member also plays an important role in durability. The cover, as we are discussing, the environment conditions are very important. If we have very mild exposure condition, normal exposure condition, the minimum cover of 20 mm may be good enough. But if we have some moderate type of exposure condition wherein there may be a risk of external attacks, then minimum 30 mm should be provided. If it is a severe environment or very severe environment, the requirement of cover goes on increasing. So for the main reinforcement, up to 12 mm diameter of bar for mild exposure of the normal for mild exposure, the normal cover may be reduced by 5 mm. So when the stresses are low, maximum diameter of bar is 12 mm, and that too with mild steel with mild exposure, then you can have 15 mm cover also. But seeing the present conditions of the different structures, I suggest that we should not go for cover less than 20 mm. Now, unless specified otherwise, the actual concrete cover should not deviate from the required nominal cover by 10 mm or 0 mm. Plus, you can increase the cover during the execution. If in the drawing the cover is defined as 30 mm, then nowhere it should be less than 30 mm. However, if it is at some places it is reaching 40 mm, that is also accepted. So my negative tolerance is 0, higher side tolerance is 10 mm. So to understand which exposure is what, the mild exposure, when we consider mild environmental exposure, the exposure conditions could be the concrete surface is protected against the weather or aggressive conditions, except those situated in coastal areas. Now, even if you are protecting these concrete surfaces in coastal areas, even then that will not be covered under mild. If in normal areas where the area is not under coastal zone, if we have protected the surface, then the environment may be considered as mild. Otherwise, it will go to moderate. So, in moderate, what we are considering in uh, severe rainfall area or freezing areas, cold areas, where condensation or rains happens, or concrete under water. Now, the important is continuously underwater, because if it is wet and dry system, then the exposure is going to be on a harsh side. But if it is continuously underwater, then we can consider it as a moderate. Concrete in contact or buried under non-aggressive soil or groundwater is also under moderate condition. If there is non-aggressive soil, or there may be, because sometimes we have high chloride or high sulfate contents in the groundwater, then it will not be considered as moderate. Then it will go to the next level. Because in severe condition, then we will say that where there is severe rain, alternate wetting drying, occasional freezing, all these conditions make the concrete make the exposure conditions to be severe. And concrete completely immersed in seawater is also severe, because seawater contains lot of harmful salts and minerals. Now, very severe condition could be that concrete exposed to the coastal environment. Concrete surfaces exposed to sea, water spray, corrosive fumes, severe freezing conditions. All these things are considered to be very severe. Concrete in contact with buried under aggressive subsoil or groundwater. If we have high chloride or sulfates in groundwater, or the soil itself is aggressive, then also for the underground construction, we can consider the exposure to be very severe, especially for the concrete which is in contact with the groundwater or the soil. And there may be some conditions like tidal zone, members in direct contact with liquid solids, or aggressive chemicals. So if this kind of situation is there, then we may have to have some special protections also, and the concrete will be classified as in extreme environmental exposure condition. So as we were discussing, there is a special requirement for minimum cement content. So for mild exposure, if we are having plain cement concrete, generally we use plain cement concrete up to M20. The minimum cement content could be 220 kg, and when we use RCC, the minimum cement content shall be 300. The maximum free water cement ratio for PCC it could be 0.6, and for RCC it could be 0.55. And the reinforced concrete M20 could be used as in mild conditions. But when we consider moderate conditions, then in moderate conditions, our cement content in RCC remains 300 kg, but water cement ratio goes down to 0.5, and the grade of concrete for RCC goes to M25. Plain concrete, of course, we can go for M15. There is not an issue. But when we go for concreting work in severe or very severe conditions, the maximum free water cement ratio reduced to 0.45, and the cement content, minimum cement content is also increased, and grade of concrete for the work is also increased, which can be used for the RCC work. Under extreme environment conditions, the RCC, if you are using, the maximum water cement ratio is defined as 0.4, and the grade of concrete to be used is minimum M40. And for plain cement concrete, of course, you can have lesser cement, and M25 grade concrete can also be used. So this table defines the durability requirement with M20 with 20 mm size aggregates, giving you the requirement of minimum cement content, maximum free water cement ratio, and the minimum grade of concrete. adjustments to minimum cement contents to for other size of aggregates, then when the aggregate is other than 20 nominal size, maximum size, then if we are using lesser size, say 10 aggregate size, the cement content need to be increased because you have now large number of more particles to be binded. So as the surface area is increasing because of the lesser size of the aggregates, your cement content requirement will increase and you will be using 40 kg more than what is defined in the above table. And if we have larger size of aggregates, say 40 size aggregates we are using for the concrete, then the minimum cement content criteria is relaxed by 30 kg per cubic meter. However, everything shall be as per the design mix. It is not that the cement content given in this code, in this table, is the only content that can be used. You can use higher cement contents, but these are the limiting minimum values of the cement. Now, mix proportioning, concrete mix proportioning, concrete mix design, nominal mix design, IS 4456 talks about quality assurance measures, batching, mixing. Now, if we talk about quality assurance in constructions related to proper design, use of adequate material, proper workmanship in execution of the work, timely maintenance and repair. These are the quality assurance aspects given in IS 456. Now, formwork and the striking minimum period before striking the formwork. Because when we are supporting a slab, we may have larger time required for the concrete strength to gain and the stripping time could be higher. And for vertical formwork, like for columns, walls, we can strike out the formwork within, say, within 24 hours. Say after the concrete has set. So generally, we consider after 16 hours we can start removing the formwork for the vertical elements. For soffit of beams also 3 days, and for soffit, because we will provide the supports back, soffit formwork for beams 7 days, and props to the slabs. If it is small span, then we can remove 7 days. If the spans are more than 4.5 meter, we can consider to wait 14 days before we strike out the formwork. Props and of beams and arches, generally for up to 6 meters, we can consider 14 days, and if the spans are more than 6 meters, we may have to wait for 21 days. But at the same time, we have to see the rate of gain of concrete strength, and 7-day concrete strength should also be considered while taking the decisions as per this table. Assembly of the reinforcement, the bending and fixing should be in accordance with IS 2502. High strength deform walls should not be rebent or straightened without the approval of engine charge. Actually, this requirement of high strength deform bars, when we were using FE 415, and generally in market we were using tall steels. So tall steel was considered to be a bit brittle, and we were restricting that there should not be unnecessary bending of the steel, and we are placing the steel for the RCC purposes. So bar bending schedule should be prepared for all reinforcement to maintain a good quality work. I have already told that the unless otherwise specified by engine charge, the reinforcement shall be placed within the following tolerances. It has to match with the drawings, and for the effective depth of up to 200 the tolerance is 10 or less. The position which can be varied here and there can vary by around 10%. Can vary by about 10 and if the effective depth is more than 200 the variation could be 15 However, as I have already mentioned, the cover, the tolerance should not be deviated from the required nominal cover by plus 10 and on negative side it is 0. So cover should not be compromised. Concreting under special conditions are also given some guidance. During hot or cold weather, the concreting should be done as per the procedure set out in the IS 7861 or 7861 Part 2. Underwater concreting, if we are doing, the methods to be used for Depositing concrete underwater shall be one of the following, by trimming, direct placement with pumps, drop bottom buckets, bags, and grout. Inspection and testing of structures to ensure that construction complies with the design. An inspection procedure should be set up, covering materials, records, workmanship, and overall construction. And we can have some testing methods also to be applied to inspect the construction. The core tests are done for, it is a kind of extraction of concrete from the actual concrete members, and these cores are then tested in laboratories to find the compressive strength of concrete. We can have load test also for beams and slabs, flexural members, and if we have some doubt about the concrete strength or some other aspects, we can go for non-destructive tests. Coming to section 3, general design consideration. When we do structural designs, we have a lot of things to do. All the students learn a lot of things during their 4th or 5th or 6th semesters. The structural design, when we talk about, we should have first confirm about the basis of design, what all assumptions we are considering in the design, what all loads and forces we have to consider. Stability of the structure is important, what all we have to check for the stability. Fire resistance, we do analysis to work out the stresses, forces. Compression members require governing reinforcement and detailing, expansion joints. All these aspects have to be planned. Now, in the design of basis, what should be the aim of design, then methods of design, then design process. All these things are covered. In present IS 456, we have limit stress method of design in the main body and working stress method in the annexures. So generally, it is recommended to go for limit state method of design as per this prevailing code. And I must tell that in the revised IS 456, it will be guided to go only for limit state method of design. Working stress method for RCC will not be permissible. Now coming to the general design considerations, we have loads and forces. The various loads we have to consider as per the various IS codes. Dead loads, for working out dead loads, we need to know the densities, and for that we have IS 875 part 1. For imposed load, we have IS 875 part 2. Wind loads 875 part 3. Snow load part 4. And then we have some special loads and other criteria in 870 part 5. Earthquake forces we have to calculate as per IS 1893. General design considerations for forces and effects. The foundation movements we can consider as per IS 1904, and all these criteria given in different parts of the different IS codes we can consider. Stability of the structure, when we need to consider overturning, sliding, probable variation in dead load, moment connections, lateral sway, and all these things. Fire resistance, if we talk, for normal buildings, generally we talk about 2R fire rating, and the fire safety requirements are governed by National Building Code of India from the part 4 fire safety chapter, and IS 456 gives us different requirements to meet that fire resistance requirement. So if we require 2R fire rating, if we have to meet 2R fire rating requirements, then for continuous beams we can have 30 mm cover, and for columns we need 40 mm cover. So this table is to be used to work out the nominal. Now, IS 456 gives us the guidance or the bending moment calculations and the analysis parameters as well. So this is the basic table when we are just talking about the gravity loads. So under gravity loads, what should be the bending moment at near mid-span, middle of end span, and then other interiors mid-span, then support spans. So these are the coefficients which can one use to work out for the simple structures where only the gravity loads are being considered. But when we have to calculate the earthquake forces also along with the gravity loads, then the analysis becomes a bit critical, and that has to be properly worked out. Some shear coefficients are also given for guidance in IS 456. Typical support conditions for loading factor shear force. So all these criteria are given. Now, when you do the detailed analysis, there are different requirements of. When we, I would say that when we are designing with limit state method of design, in limit state we have a requirement to control the deflections, and to control the deflections we have in IS 456 given some span to depth ratios which need to be met, which we need to meet, and in those span to depth ratios we can have some improvement by giving some modification factor. If we are providing compression reinforcement, say 0.5% is the compression reinforcement, then almost 0.15 is the modification factor we can use for the span to depth ratios. Suppose your span to depth ratio is 20, so we can multiply this 1.15 to the factor 20 to have a safe limit of the span to depth ratio. The section 3 requires requirement. I think I skipped the tensile also. Okay. So requirements governing reinforcement and detailing. A lot of detailed requirements are given in the code for reinforcement, placement, detailing. From earthquake safety point of view, IS 13920 gives the special confining reinforcement requirements and so many other things which we all need to know. Clear distances between the bars is also given because we do not want a lot of congestion within the reinforcement members and should have adequate anchorage of the reinforcement bar with the concrete. So if we are having lesser space clear distances, then the moment distribution and other aspects gets affected. So this code gives us the distribution percentage redistribution to or from the section considered. If when we consider 0, it means if we are having the spacing like this, 300 mm for normal 250 grade steel, which we are generally not using, but for 500 grade, if we have 150 mm spacing, then we need not to worry. There, then it is a normal section to be considered. Special design requirements for structural members and the systems. For corbels, deep beams, ribbed hollow blocks, voided slabs, flat slabs, walls, stairs, footings. For all these special elements, the requirements of structural design have been specified in IS 456. So I am not taking all these into because this will become very technical in this nature. Staircase designs also, what should be the span to be considered? Generally, we can consider the span to be from the center of the landings, and that is how we calculate then the bending moments. For footings also like this. So these are the different structural design criteria. Partial load carrying partial safety factors for limit state of collapse. When we have dead load plus imposed load, we have different load combinations like dead load and live load 1.5. And if we are considering wind load or earthquake load, it can have 1. And in limit state of serviceability, we can have 1 dead load, 1 live load. Similarly, dead load plus wind load, if we consider it, then we can have, if the wind load, if the dead load is stabilizing, then we are considered 0.9. And if the dead load is not stabilizing force or moment, then we can consider 1.5 times dead load and 1.5 times wind load during the analysis of the collapse. Similarly, now in the revised standards, these load combinations will be dealt in detail, and so many different load combinations have been specified. And it will, whenever this IS 456 revision will come, you will see a lot of load combinations for various conditions. Section 5, structural design limit state method of design. When we have to design for shear, the code gives the design shear strength values based on the tensile steel provided in the max section. Suppose if we have provided 0.5% reinforcement steel in tension zone, then and your concrete is M30 grade, then for 0.5 and M30, you have 0.5 Newton per mm square is the shear strength of the concrete. So if your shear stress is within this 0.5, then you may not need any special shear reinforcement or stirrups or ties. So this is how we calculate. Nominal shear stress we calculate based on the shear force divided by B into D. So in any section, as we were seeing that with 0.5% tension steel, for M30, our concrete shear strength is 0.5 Newton per mm square. And code says that if it is the value of shear force is going more than 3.5, say for the same M30, then we have to increase the cross section because the code do not allow the shear stress more than 3.5 Newton per mm square for any at any section for M30 grade. So this is the limiting value of shear strength, because even if you are providing the shear reinforcement, the overall shear force at any section or at overall shear stress at any section should not increase more than the values given in this table. So these are again some values that how the shear works, and shear generally has an angle of to 30 degree. In normal designs, we consider 45 degree. So maximum shear stress values we have considered. Some list of Indian standards have been referred in Annexure A, which were considered while making the provisions of IS 456. Annexure B talks about the working stress method. The modular ratio and value is given as 280 by 3 times sigma CBC, permissible compressive strength of cubes. So, but these methods are now not in use. So, it is just an annexure for the guidance of how earlier days we were designing this structure. Calculation of deflection we can calculate. There are, I would say, there are methods given in the code that how we can calculate the total deflection, short-term deflection, deflection due to shrinkage, and deflection due to creep. For slabs design, this annexure D is giving the bending moments, how we have to calculate the bending moments for different ratios of the long span versus short span. So if the short span coefficient x alpha x given in this main table, if the ratio is 1, it means though both the sides of the slabs are same, then the ratio is 1. If the smaller span, the larger span to smaller span ratio is 1.1, then we have to consider this other column, and that's all. And when the larger span to shorter span ratio becomes 2 or more, it becomes one-way slab. So for all those, that value has to be considered. So long span coefficients are also given, and based on these coefficients, we can calculate the bending moments of slab, and then slabs can be designed for that. So this is the given value. Then effective length of the compression member, how we can calculate if both ends are fixed, effectively held in position, restrained, then recommended effective value of length is 0.65 L. Theoretically, it is 0.5 L, and recommended value for using in the structural analysis is designed to be 0.65 L. Similarly for other conditions. Annexure F gives us the method for calculation of the crack width of the concrete. Now here I would take 1 minute to discuss that. Generally, when we design our concrete sections, we consider that in the tension zone, the concrete will crack. That is how the basic principle is, that we provide the reinforcement steel in the tension zone to prevent the collapse and to give the adequate strength. Now, even if we are providing reinforcement steel, the concrete will crack in the cover zone or the below neutral axis zone. So the limit state of design also recommend us that for normal designs we can have maximum crack width to be 0.3 millimeter. For buildings in adverse environment, or I would say that durability, if there durability is an issue, then we should use it to be 0.2 millimeter crack width. And for water, say the surfaces which are continuously in touch of water, or say water tanks, sewage treatment plants, or maybe some other surfaces where we are having concrete in touch with the water or a very aggressive environment, then we should not have crack width more than 0.1 millimeter. So based on this details of annexure F, we can calculate the crack width and we can satisfy the limit state criteria. Annexure F, again, it gives the detailed basics how we calculate the crack width. Then simple formulas are given that based on the concrete stress strain curve, how we should calculate the XU, effective depth of neutral axis, and how we can calculate the moment of resistance for the RCC structures. And with this, now I'm coming to the closer, that we have to consider the environment also when we consider our analysis and designs. Concrete as such is a very durable, good material and sustainable material if we are able to make very long life structures. And just to have these two slides, I'm considering in my presentations that we should look about the sustainability and the green environment. And local available materials can also be used, like bamboo and other sustainable materials. National Building Code covers the detailed requirements of design using bamboos also. So let us try to save this planet using green materials. In concrete also, we can use greener aspects by maybe using PPC cement or using mineral admixtures along with cement or along with OPC cement for making good quality concrete and having higher durability and sustainable considerations. So with this, I thank you all.
Thank you, Amandeep sir, for giving us introduction about IS 456. That is nothing but NBC's Part 6, Section 5 on concrete. And thank you so much about this. I mean, and just I have one not question, but can you inform us about, just in 1 minute, that what are the basic principle being changed in the new revised version of, I mean, which is coming
We are all
for,
waiting. Yeah.
yes.
Yeah, as I just mentioned that we are now going away with the working stress method of design. We will be using only the limit state method of design. And in the limit state methods, presently we have two considerations. One is the limit state of collapse and the other is limit state of serviceability. We are basically considering these two aspects. In limit state of collapse, basically we are considering the strength aspect, and in limit state of serviceability, we are considering the crack width, durability, deflection,
Vibrations.
vibration, all these aspects. So beyond this now, the IS 456 is saying that we have to see the limit state of robustness, limit state of integrity, and maybe if we have to redo some, if we have to retrofit accessibility and all of
Repairability.
it. So all
Yes.
these aspects have also to be considered now when we will be having this IS 456 revised. Besides that, we will be having design consideration for very high grade of concretes. So this current code, we may not have very high strength grade concrete strength requirements, design requirements. We will be having shear coefficient requirement, coefficient for the higher strength of concrete. And maybe a lot of changes are, because this is a complete overhauling of the construction industry requirement. So a lot of quality related aspects will also be covered. Durability has been defined, limit state of durability has been added as a major chapter, because now at this moment what we are considering durability is just by some cover, some minimum cement content, or some limit of the water cement ratio. But now after this revision, we will be actually calculating based on the expected design service life. So a lot of improvement, I would say, thrust is there. Basic philosophy of limit state design remaining same
Okay.
for normal concrete, but we will be having some extra things to make sure that we are moving ahead for a better concrete, for a better structural environment.
Yes, thank you, sir. And with this, I believe I request all of you that you please go to this wide circulation copy of IS 456 and you can comment. And last date for comment is, I think, 26th of February. And you can send your inputs, your comments, so that we can consider it in the next meeting of when we discuss about all the comments we received on IS 456. And of course, we'll have revised version in 2025 of 456.
Interesting.
And with this,
Yeah.
I sincerely thank Amandeep sir for giving us all the introduction about IS 456 2000 and giving us the highlight of what is going on in the revision of IS 456. Thank you, sir. Thank you so much.